I'm Stefan Niekamp, and we are here at UCSF in Sean Douglas' lab, and we are working on DNA nanotechnology. For instance, we're developing devices to fight cancer in the future. And I'm here as an exchange student from Munich, from the Technical University, where I'm enrolled in my master's program at the moment. And this summer I will start my PhD here at UCSF in biophysics. Thanks. In the first place, I would say actually the teachers, because they really talked to me and I learned a lot about physics. And actually I really loved physics, so I started to study physics in Munich at the Technical University. And this was just plain physics, and then I really worked in superconductivity. But later in the summer school, I figured out that biophysics is even more fun because you can apply it to really life science and therewith help people. So that's what I really enjoyed. And then in Munich, there's Hendrik Dietz's lab, and he's actually a friend of Sean Douglas. And so he's working on DNA nanotechnology too. And that's how I got introduced into DNA nanotechnology.
So my name is Sean Douglas, and I'm an assistant professor. One thing that we're trying to address is how to build chemotherapies or better cancer therapeutics. You'd want it to be safe and effective, and you'd actually want it to destroy only the cancer cells and leave everything else alone. So you want to spare all the healthy cells.
Well, first thing, usually if we build a structure, we use a computer to design our structure. There is software you can use like CatNano. And then we can order all the DNA we need to make our structures and then run it on a gel electrophoresis. And this helps you to separate the structure from not folded structure in a way. And you can look at that. And then later you can cut out this specific band from your gel and then use that, purify it, and apply that to a device which you later insert into your microscope to look at it. And the microscope is a transmission electron microscope, so that means it's basically like a light microscope, but in this case you're using electrons to look at your stuff, and you're not using light. Electrons in a way as light, as you might know, so they can behave as waves or as particles, and you can use them to get very short wavelengths to look at very small things in nanometer scale, and that's what we are doing. And then using this microscope, we can really see how our structure looks like. So first on the computer, we really design it. Then later, if you can see it on the microscope, wow, that's really great fun. So if you can see that stuff is something I designed and I made and it works, that's always a great moment. This will be very... And yeah, as I said, so in physics, I did superconductivity. And that's something where I really didn't see what effect you can really have on the life of humans. So with this, it's way closer to that, and that's why I'm really excited about that. And I still can use my physics way of thinking and the knowledge and apply it to a different kind of subject now. But it's still in a way you still can think as a physicist, so that can still help to solve these problems. So if we really can figure out all these steps we need for drug delivery to help fight cancer, that would be really awesome. But I know for sure that it will take a while, but I hope we will get there in the future. But that would be a really great thing to help people with and to fight cancer. So this is one of my big aims, actually. So.